Jump in quickly. Hi, my name is Stacy Sneeringer. I'm an economist at the Economic Research Service at the USDA. Okay. So just a quick note, I think pretty much everyone in the room maybe knows what Economic Research Service does. We are a lot of economists. We're a lot of economists in one building together. Our mission is to anticipate the trends. They were talking earlier. We need to kind of see into the future in order to produce research that would inform policy areas that are going to be pertinent from 10 years from now versus just right now. Anticipate trends of emerging issues in agriculture, food, the environment, and rural America. We also conduct in service of that, we conduct high-quality, objective economic research to inform and enhance both public and private decision-making. A note is that our goal is less to inform an individual farm operation about how to run their farm than it is to address policy questions. Those policy questions, of course, will affect individual farms, but our goal isn't to say, this is what's best for you. Right, an individual. So our results are publicly available, and we are also a trusted steward of confidential data like NAS. So we don't, we are very careful about releasing farm data that could be, if you could identify an individual farm, for example. ERS and big data, we've been doing a lot of things in this area for, as noted, several decades. There's been a lot of capacity building in this area, so we've been acquiring and what we call curating this proprietary data, both the administrative data and the proprietary data. So some of this we participate in collecting with NAS the Agricultural Resource Management Survey data, ARMS data. There's a lot of curation that needs to be done with that because what you get is not necessarily something that any economist could use immediately. We've also been investing in research on the quality and the properties of alternative data sources. So for example, scanner data. Scanner data would be somebody, there's maybe like 35 billion observations of this. And so what it is somebody scanning everything that they bought at the grocery store. Now, that's not necessarily representative of a population, but the question is how can we maybe attach a weight to that to see how to make it indicative of and representative of a population. We've invested in bringing structure to that big data, meaning just the curation and exploring these new data opportunities that you've been hearing about. The types of data, Dr. Swinton already kind of suggested these. The survey data, the census data, that's statistically representative, and that's a major source of its value. It's often addressed to collect specific, or collected to address specific questions. So for example, the ARMS data is collected to examine farm financials specifically. We tack on other questions that can address other questions that are maybe related to the farm and the farm productivity, but it's specifically addressed at that. There's also what I'm calling uncurated data, which is a lot of what we've talking about in terms of the sensor data, the scanner data, that might be satellite data as well. It's not collected for the purpose of statistical representation, and you need to kind of really work with it. It might be enormous, and trying to deal with it even in your home computer is not going to work. And then I have the administrative program data. This is not necessarily statistically representative. It's who receives benefits or who's in a program, how much do they receive in the benefits, and it often does need further curating in order to use. And so the initial slide with those Venn diagrams, it's the question of maybe using it in relationship to another data source. So in having conversations with my colleagues just at ERS about what is big data and what is big data research, everybody seems to have a different idea of what that is and what falls under that umbrella. So I've come up with 3 ideas about that. First of all, it's the methodology of curating this big data, and I think this is the figuring out how to use all of this sensor data along with the administrative data, along with the survey data, is one thing that you're talking about with curating this data. You need new methodologies, you need new computing power, you need new platforms to curate that data. There's also an idea about what I think we've already just heard is using these kinds of data in novel fashions, that maybe they weren't collected specifically to address a certain question, but you're going to basically use the data in a different cut, for example, or in association with something else in a novel way, so you can address a question that the data was not intended to be used for initially. And there's worries about doing that in a statistically represented way, of course. And then we've been hearing about this questions of access to the collected data. A second big part of the big data research umbrella was using that curated data to answer research questions. So once you get it, once we get the wheat estimates, what can we address about the wheat estimates? So, for example, policy questions would be, do you have a commodity payment program, for example, or something that would affect wheat yields? Is that working here or there? What does that do? So those are the kinds of research questions that economists tend to try to answer. And the third would be kind of the more abstracted question is, once we have these new big data sources, once we can maybe reduce some risk, some uncertainty around certain issues, what happens, right? Who benefits from that and who doesn't benefit from that? If someone does have access to that research or that data and somebody doesn't, does that create a new scale economy in the market? We heard a question earlier that was specifically around these issues. When you shut maybe the smaller farmers who cannot have, don't have the capital to invest in this data product, what happens in the markets there? Also in terms of if you're trying to talk about maybe refining your yield estimates for corn, what you're getting is a better, a less certain or less risky estimate for perhaps a futures market. And so you're talking to the stock market then, and what happens there when you have those kinds of new estimates. So those are the kinds of abstracted issues that would be more about not necessarily using the data, but what does the data do to markets? So I have several examples from the ERS, what we've been doing in terms of using the data and what would be called under this big data research umbrella. A research question was, how does individual farm household income vary over time? The issue is that we don't collect we don't follow individual farms over time in terms of their financials, okay? We collect a lot of cross-sectional data, and we've been doing that since 1996, but we don't have a panel across those. So the solution was to try to put all of that together and actually create a panel. The author will not call it a panel, he will call it a pseudo-panel because he is desperate for you to not think that this is statistically representative. But when you compare what they get to other indications of what farms look like, you can kind of characterize these as commercial farms. So the issue there is what we want to understand is how does farm income vary over an individual farm? So if you just take a cross-section of farms, you're gonna basically, and you're just gonna smush what the volatility is between farms, okay, for that individual farm. You're not gonna get a good indication. So what we do is we use the ARMS. The ARMS is this very large, complex survey that does require a lot of curation to actually get to a usable format initially. And what we did was, or what people in my division did, was you find the farms there in every single, or at least in the ARMS twice. So you get down to 38,341 farms from many, many more. And so for an example, sample result is that farms, yes, have a very high degree of income variability at the individual farm level. So what this is showing you is farms that started with between $75,000 and $125,000 in initial farm income, and this is the change in thousands of dollars. So that bottom number is 200,000. So initially they've gone into debt, okay? And the other one, the top is 400. So this is suggesting there's a large degree of income variability for farmers. This is using both on-farm and off-farm income, but you see that basically they're not being able to adjust with off-farm income to basically make sure they stay in the zero and above level, okay? Another one, here's maybe a better example of what we were thinking of in terms of big data. Farmers sign these conservation contracts with the USDA. This is a program administered by the USDA. An example would be to receive financial assistance for adoption of no-till or reduced tillage adoption, okay? So the question becomes, we have a lot of information about the farmers who go into the program, but so they would be called a treatment group, but we don't have any information on a control group, those who do not adopt the program. So do they serve as controls? And the question also becomes, if your neighbor adopts, are you more likely to adopt? So there's these kind of neighborhood peer effects that we'd like to look at too. Now we don't know anything about the ones that don't adopt, so how do we get that? Well, a hugely complicated problem, as I found out as when I was talking to the authors of this. What they've been doing is building these, they take the satellite imagery of individual pixels, and basically you have to, so here's an example. This is an example tillage classification. So in essence, you take the satellite imagery and you're saying, okay, what does blue mean? I mean, it's interpreted as blue, obviously, by whatever computer interface it's using. But does that mean medium till, high till, low till? What does that mean? Okay? So trying to ascribe some meaning to that pixel color, okay, in fact, is a giant process. What this has done here is they've done an initial qualitative classes of those things in terms of tillage, okay? But the other thing is that they're going to relink it back to some of the survey data, so you can say, okay, I know what that pixel is, I know what farm level that is in my actual survey data, so I can geocode that, and I know what's going on in that pixel, right? So then I can say, okay, I can check to make sure my characterizations of things is correct, okay? And then I can then say, I'm pretty sure that's good, and I can do that with thousands of individual pixels, and then I can make sure that I'm getting the rest of the pixels that are out of sample. And then I take the program data, and I put it back, and then I have both program and non-program data, okay? And so it's this hugely complicated thing that you don't realize is going on in the background, but is one example of big data research that's going on at ERS. Another example, okay, I won't go through these, but another big issue is that these big data enables new methods to fit models, and we've done some capacity building in terms of hiring somebody who doesn't have an econ degree but just has an engineering degree in order to try to start using machine learning in order to basically work with this data. So you have so many bits of information that it becomes that I'm going to econometric nerd out, you could overfit your model, okay? So you need a new algorithm. So basically because you want to reduce the dimensionality at some point. And that's what I get for econ nerding out. I get it. That's the alarm. So you can basically start to develop these non-parametric models to control for the unobservables and the observables. There's a schematic. I won't talk about that apparently because I'm going to get an alarm. So some conclusions. These are not the only types of big data research at ERS. The major example that I didn't go over was the scanner data. We've been doing research with the scanner data for decades. A note, again, that we've already reflected this, is that the prediction so for example, even when we get the tillage levels, that doesn't tell us about any kind of causal inference about what affects tillage and what doesn't, right? We have to go back to other sources of data to start to analyze things, and that's where we get information about which programs would work and which programs don't, or how to more efficiently administer programs, right? So do we want to target a program to the farms that are most at risk? Do we want to target a program to an acreage that is most at risk for soil erosion, for example? The purposely gathered data were still necessary. We saw that the satellite imagery is also used for cross-validation. It's used for algorithm fine-tuning. It's used for answering the questions not covered in curated data. So for example, if we have a lot of soil sensor data or variable rate technology data, that still isn't going to tell you about the farm financials, right? And so we're not collecting farm financials. I mean, I'm sure there's some Google algorithm out there that is, but we're not. But we also want to have statistical representation, okay? And statistically representative of agriculture in the U.S. And so we can't really get that without actually just being very specific and using statistics and using, you know, the education that people have at NAS in order to fine-tune those surveys. Okay, so thank you.